Why am I recording? Because I will not be present 8th period today. So they need a video to watch. Yes. So
hey guys.
This is not going to be my best production here, but hey. All right, here we go. So instead of surface area, which you guys all worked on the outside, now we're going to go inside a figure. So volume, space occupied inside a figure. All right, space occupied inside a figure. And before I got to the volume of any figure today, I wanted to talk about one principle here called Cavallari's principle. I assume that's the person who discovered the principle. Here's what it says. I'm not going to spend too much time on it, but it did come up on a Regents exam a couple of years ago. If you have some type of polyhedron, or two of them, let's say, two polyhedrons that have the same height, and I show you a cross-section of one and a cross-section of the other, and those cross-sections have the same area, those two polyhedrons have the same volume, no matter what they look like. So take a look. Everyone see I got the just straight up rectangular prism here in the first one. And then I kind of leaned it over to the side. They look different, but they have the same volume. Why? One, they have the same height. Two, let's say I sliced it horizontally. I'll have the two rectangles showing to you. Both cross sections have the same area on them. Both rectangles, cross section have the same areas. Same thing here. Whatever you want to call these, pizza boxes, whatever. They all have the same volume, even though this one's nice and sturdy. The middle one's okay, and then the third one's just a hot mess. All right, they all have the same volumes. Why? All have the same height. And if I took a cross section and showed you this cross section, and this cross section, they're all going to have the same area. So that means they have the same volume. Take a look at these here. You'd probably be like, no way, they look totally different. There's no way they have the same volume. Actually, they do have the same volume. So my point of Cavallari's principle is just because they look different, one's tipped, one's straight, standing straight up, they still have the same volume if, I'll let this finish. Okay, whoa, I didn't know we were going to go reverse here. If they have the same height, and you see what I'm saying, the same cross-section area, because these will both be triangles that'll have the same area. All good? Cavallari's principle. Last thing on that, the bases can be different shapes and still apply. This can still apply. Rectangular versus triangular prism, everyone agree they both have the same heights. Yes? If you do a cross section here, you're going to get a triangle. If you do a cross section here, you're going to get a rectangle. But if they still have the same area, the areas are equal, they have the same volumes. All right, that's what Cavallari's principle says. Same height, same cross-sectional area, equals same volume. All good? Let me show you that Regents question that came up. I got 23 quarters stacked. One is nice and neat. The other is just out of control. Using Cavallari's principle, explain why they have the same volumes. Same volumes because, one, what do they both have? Same height. Because same height. And two, if I took a cross section of one and a cross section of the other, held it up to you, where are they going to be? What shapes are they going to be? Circles. And are both circles going to have the same area? Yeah, because they're both the same type of coins. See what I mean there? All right, so it doesn't matter where I go here on my cross section, I'm going to get a circle, another circle from this stack here, and they're both going to have the same area. Same heights, same cross-sectional area. All good? All right, so there's Cavallari's principle. Now to some volume. Good news for you guys on this last half of the year of new stuff. Go to your formula sheet if you have it on you. If not, it's on the back of your packet. You are given all the volumes. Okay, everyone see all those volumes there? Okay, you are given all the volumes of all the figures we are going to talk about for the remainder of the unit. Starting with Prism. And you guys see general Prism volume is BH. Now, real quickly, the capital B stands for area of a base. Now, you guys know rectangular or prisms have how many bases? Prisms, how many bases? 2, but I'm only taking the area of one of them here. I don't multiply it by 2. So area of a base, and then H is going to be height of the prism. All right, make sure we're aware of that. Height of prism. All right, height of the prism. And since they give it to you on the formula sheet, I'm just going to go right to it without doing any examples. Volume of a cylinder. It's still BH, but since B is a circle, we can detail it to pi r squared. There's your B, right? Circle times the height. All right, let's get into it. Calculators, calculators, calculators. All right, find the volume of this triangular prism. So if you go to your formula sheet, if you remember it, volume equals area of the base times height. All right, what shape is the base up here? Triangle. All right, we've done this 2 units now. So we're going to go 1/2. What are the base and the height of the triangular base there? It's a right triangle. So it must be the 2 legs. So 1/2, 8 times 15. That's big B right there. That's capital B. Oh, good. Okay, here's where I start getting nuts. H is the height of the prism. Reminder from earlier in the unit what height is? The distance between the bases, or the edge that connects the bases. How long is that edge? 8 meters. It's this way. It's this right here. That's your height times 8. Any issues on big B, capital B, and versus the height of the prism? And we end up with 480. Anybody want to clue me in here now that we're doing volume? Cubic meters. We're not doing area, we're doing volume, cubic meters. Questions? All right, let's just hop right into the honors level ones. What do you say? I got a rectangular pool. There's the volume, length, width, depth, and a ratio 10:1. Find the dimensions of each for me. Come on, we're in May 13th here. 5 weeks away from that Regents exam. What are we doing with the numbers in a ratio? Put X's with them. If you want a visual, why am I even trying here? Yep, there we go. Length, width, height. There we go. Depth. I'll still start out with the formula on the formula sheet. BH, volume, 10,080. All right, what's going in for big B? Even if you mess up, it doesn't matter because we're going to end up multiplying everything. But 4x times 10x times the height. Times the height. X. Oh, boy. Oh, go ahead. Show off your algebra skills here. What do you get when you end up 4 times 10? That at least gives you 40. X. We're going to Algebra 2 next year. X cubed. Next step. Divide by 40. X cubed equals 27. Have I gone? I don't know if I've gone over this year. Usually if that was a 2, you take the square root, but now we take the cube root. And where is that on the calc? I know definitely where to get to it. You can
up button, like the little caret thing. Like put the number.
That would be raising it.
Yeah.
But I want to cube root it.
Oh, cube.
Not cube it. Cube root it. The best way I know, go to your math button, and you'll see the choice right there. Hit your math button. Everyone see choice 4.
It's 3. No, it's 4. It's literally 3.
Yes, it's 3.
Oh,
I meant choice 4. I meant there's choice 4.
Oh, yeah, I meant choice 4 too.
Good story. No, I guess there's no shortcut. Maybe there is, but you can hit it right to
If
math.
there is, I'll find it.
Yeah, I'm sure you will.
I will.
Yeah.
I feel like math 4 is
Mr. Curly, do you know how to play like games on your calculator?
He doesn't.
I prefer not to. All right, I prefer not to.
No, but do you know?
Like I don't have the ability to put them on calculators. No.
Oh. You
don't?
don't? Like download it. Seen it before.
Yeah, you got to download them.
How do you do that?
I don't know because it doesn't it doesn't affect me at all. Matt.
The question was asking for finding the units in each of the 3 dimensions.
Yeah, it was.
Okay.
That's a.
Have I gone to the next slide yet?
You just circled it.
Because that's one of the answers. Can I write down the other answers?
Okay.
Have I gone to the next slide yet? Have I even started reading the next problem yet? How about me just saving myself right there? That was pretty good, huh? Pretty good right there.
You actually got really defensive.
So 12 meters and 30 meters.
Oh. And 3 meters. Yep.
All circled. There's nothing you can get on me about there.
Well, after what just happened, period A might be a little confused. So
They might be, yeah, because you know those period 8 kids. Yep. Top class I have right there, period 8.
That's not what you said yesterday.
By far.
We all know you're lying.
Yeah, okay. You know the rankings. You're right after my study hall. All right? You know the rankings. Actually, my hall duty. All right, let's go to Big Jed. Here's where we're going to live, these type of problems. You know, I know you guys can find the volume just by giving some numbers and plugging it into a formula, but I need you to do something with that volume. All right, so this is where we're going to live here for the next rest of the unit. His generator runs 2 hours. Ooh, on a liter of gasoline. Yep. Rectangular prism. Jed fills the tank with gas. How long is it going to run? Ooh. And note, I gave you a little conversion here. For every 1,000 cubic centimeters, that's a liter. So I see cubic centimeters. That automatically tells me we're not in the area part. We're not in surface area. We're not in lateral area. We're in the volume. Yeah, we're in volume. And it's a rectangular prism, so I'm going to roll with BH. $15 times 20 for the area of the base, times 10. And yes, if you're picking this up, it's length times width times height for rectangular prisms. All right, here we go. So calculate that. I'm getting that generator has 3,000 cubic centimeters of space. So if I'm looking for how many hours can it run, I need to figure out how many liters of gas it can hold. And we have a conversion. For every 1,000 cubic centimeters, it holds 1 liter. What would you like me to do to the 3,000 now to find out how many liters? Take the 3,000, divide it by the 1,000 for every liter. And this tank can hold 3 liters. All good so far. How I got it can hold 3 liters. And all right, now let's get to the number of hours. It will run for 2 hours for every liter of gas. What's your next move? Runs for every 2 hours on every liter of gas. I got 3 liters. 2 hours for every liter. I got 3 of them. We're looking at 6 hours this bad boy can run. Any issues? Are we okay with that? Because they're either going to be the same level as that or tougher than this one. All good? Cylinder. Basic cylinder question before I get a little bit more complicated. Height is 7, base diameter of 10. What's the volume? Leave it in terms of pi. If you go back to your formula sheet, pi r squared times the height. Just be careful. Radius. Radius. 5. Squared. Tells me the height is 7. We're good to go. Just remember to leave your answer in terms of pi. So yes, leave that pi on the paper, not in the calculator. $175. Pi, what's in my units here? Cubic centimeters. All good? A thermos. Anybody still have those nowadays?
I actually do. My
Put them
dad,
in your old
my
school
dad
lunch
got these-
boxes
okay.
and
my dad got these hydro flask ones, and they're so
cute.
nice.
They're so cute.
It's like high tech.
good deal. Well, we're going to fill it with coffee, but notice we're going to fill it to 1 inch from the top. So we're not filling it all the way. I give you the height and the radius. How much coffee is in the thermos? Not what's the volume of the thermos, volume of the coffee in the thermos. It's 12. What's the height of 12 inches? But again, we're only going to fill it 1 inch from the top.
Ew.
How much coffee is in there? Okay, it's the coffee still takes the shape of a cylinder. We all agree? So I'm still going to use pi r squared times the height. Radius is still 2.5 squared. The only thing I need to watch out for, I don't want to use 12. I want to use 11. 1 inch from the top, 12 minus 1, 11 inches for the height of the coffee. Round to the nearest hundredth. And then how much coffee in this bad boy? 215.98 cubic inches. All good? All right, the old barrel of fuel oil. Cylinder. All right, what do we know? Diameter, 22.5, the diameter. Height, 33.5. And there are 231 cubic inches in a liquid gallon. How many gallons? All right. Again, this is a conversion one at the end. I got to do something with my volume, which, by the way, I should have backed up here. How do I know this is a volume question and not something from surface area? What up there signals to me, you better find the volume.
Cubic inches.
There are 231 cubic inches. So the only way I can convert it is if I know the volume. Pi r squared times the height. Hey, how about that radius?
It's 11.25.
11.25 squared times the height, 33.5. Yep. Is this going to be our final answer?
No.
And again, I always ask that because you're not going to. Good talk. Round it. Round it. Yes. So there's my volume, about 13,319. Now you got to get to how many gallons? 231 cubic inches in a liquid gallon. And look, I get it, and some of you probably don't want to admit it, but you know it. What do I do with that 231? Is it multiply or divide? And really, some of you are just going to guess, and hopefully it's a 50-50 shot and you guess right. So let me just show you a quick way that you can never get this wrong, whether you divide or multiply. Make a proportion out of it if you're ever confused. First, write the conversion. 231 cubic inches equals 1 gallon. Write the conversion. Make a proportion out of it. Our volume was in cubic inches, so make sure it goes underneath the cubic inches in the conversion. And you can solve for what's remaining. So now as you guys cross multiply, hopefully it becomes obvious now that you don't multiply by 231, but you have to divide by 231. Because you'll have 231x times the volume times 1. And the only way to get x by itself is to divide both sides by 231. So write a proportion if you're ever confused. Write the conversion, make a proportion out of it, then put your volume underneath the other volume. So number of gallons. Where are we going? Nearest 10? I have 57.7 gallons. Because that's the last thing I want you to struggle with is, do I multiply or divide? Set up a nice proportion. All right, anything here before we end it with a couple more? Oh, you know, I had to throw in a little different kind of prism at you. What type do we have here? Hexagonal prism. Find them, not the surface area, but the volume. So it's, I don't care what the base is, it's still a prism BH. Can you guys just plug in the height for me right now? What's the height of this prism? 8. Distance between the hexagons. Ooh, you ready for Big B? I hate it when he does this. Here's Big B. Get my hexagon out. There it is. Nope, there's not. We're on fire here. Try that. There we go. All right. I don't know how many times we've done this in the last unit. Surface area part of this unit. How do you find the area of that hexagon? Well, it's already going to be what? 1/2 or 6, excuse me, because I'm going to form 6 triangles. 1/2, I already know the base of one of those triangles is 6. I need your help finding the height now. Again, don't use 6. That height cuts it in half, so we're going to use 3 here. What's this top angle here? 30. It bisects the 60. So I'm given the shorter leg, got to find the longer leg. What do you got for me? 3 radical 3. Let's go there. So area of the base, 6 times 1/2 times 6 times 3 radical 3 times the height of 8. Should add simplest radical form here. Should have. Ooh, I'm hoping this is right because I have something erased on my notes. 748.2. No, nope, that nearest 100. 2 what? 2.5. Any issues? And just like surface area, let's put some stuff together and find the volume now. Find the volume. I don't know. You look on your formula sheet. Is there a formula for an L on the formula sheet? I don't think so. All right. So it looks like we're going to have to divide this up however you want into 2 rectangular prisms. We can do it one of 2 ways. You can draw a little vertical line down right here, or you can draw your horizontal line going that way. Because I want you to do something independently here today. Go right ahead. Choose your adventure. Let's see, no matter how you cut it up, if we end up with the same volumes. Same thing with period 8. Go ahead, cut it up. Give you guys a minute and a half, 2 minutes.
Basically.
$76 cubic feet.
Oh yeah, see the answers.
Questions? Going? And then I do have good news, and some of you probably have already figured this out with number 9. Remember with surface area, we always had to worry about what was covered up. Well, this is volume. We're filling up the inside. We don't have to worry about that at all. Okay, we do not have to worry about what's covered up because now we're filling up the inside versus what's on the outside. So here, what's this made up of? We have a rectangular prism, and we'll add to it, what's this bad boy here off to the left? Half a cylinder. And that's exactly what I'm going to do for their volumes. I am not going to be worried about what's covered up. So I'm going to do BH for the prism plus 1/2 pi r squared. I'm just going to plug my numbers in. You do not have to worry about what's covered up with volume. All right, so help me out here. I got 11 times 6 for the base. What's the height of this prism? 8 inches. Plus 1/2 pi. Ooh, what about the radius? There's a couple ways you could get the radius here. What's the radius of this half cylinder?
8. Well, the diameter is 8.
Diameter is 8, so radius of 4. And you could do this a couple different ways. 15 minus 11 gives you this piece, the radius 4. Or you could use this edge, which matches this edge, and cut it in half. 4 squared. And we're rounding to the nearest whole number. (679 cubic inches). You all right?
Yeah.
Oh, I forgot the height, didn't I?
Yep.
Times the height. Height, okay, all right, here you go. Height of the cylinder. That's on me, I forgot the height.
6 and 8.
Height, what's the height of my cylinder up here?
Oh, so I was right before. Oh,
You're so right.
Height of the cylinder, distance between the bases.
it's 8.
Hey, look. Here's a base, right? Base in the back. Here's the edge that connects them. That is 6 units. So the height should be 6 there. This is why I record 8th period.
What did we do? We didn't do anything.
It's not us, it's him.
Oh, okay.
Really laying on thick with 5 problems there, so go ahead and start them.